Yeah, good afternoon to all of you. My name is Krishna Reddy. I am the ex-faculty member of the Narayana Academy regarding the NEET and IIT programs. Today I discuss about very important topic regarding the all concepts of the chemistry that is called hybridization methods in the shortcut way of the approach. So go to the shortcut way of the approach. See the students. So today class we discuss about hybridization. See what is the formula of the hybridization? First I explain the shortcut formula of the hybridization. Hybridization H is equal to group number of central atom. So this is the one of the shortcut formula. See group number of the central atom plus number of surrounded, what am I saying? Number of surrounded monovalent atoms. What I am saying, students? Monovalent. What is the monovalent? Single bond formation. Plus or minus charge by 2. This is the one of the shortcut formula for what? Hybridization methods. Okay. See, repeat the formula once again, students. So, what is the shortcut formula for hybridization? So, group number of the central atom plus number of the surrounded monovalent. What is the meaning of the monovalent? Single bond formation. Okay. Plus or minus charge by 2. This is the one of the shortcut formula for hybridization. Yes. You are very well known. Yes, you are very well known regarding the concept of this hybridization. In the atom, what are there? Orbitals are there. What are the orbitals? S orbital is available, p orbital is available, d orbital is available, and f orbital is available. So, the s orbital is near to the nucleus compared to p. P is near to the nucleus compared to d. D is nearer to the nucleus compared to the F. Yes or no? So basing on that, these atomic orbitals are involved. What am I saying? These atomic orbitals are involved in the process of the hybridization. Now, basing on that, when the atomic orbitals are involving, you get different types of the hybrid orbitals. Now, how you get the different types of the hybrid orbitals? Now, see. So, if S comma P orbitals are combined, you get sp hybridization. What am I saying? S comma P orbitals are combined, you get what? Sp hybridization. S comma 2 P orbitals are combined, you get sp2 hybridization. Yes or no? S comma 3 P orbitals are combined, you get sp3 hybridization. Okay, Nana? What am I saying? S comma P orbitals are combined, you get sp hybridization. Okay, and S comma 2 P orbitals are combined, you get sp2 hybridization. S comma 3 P orbitals are combined, you get sp3 hybridization. Yes or no? And S comma 3 P orbitals comma 1 D orbital is combined, you get what? sp3 hybridization. What I am saying? sp3d hybridization. What I am saying? S comma 3 p orbitals comma 1 d orbital is combined. You get what? You get sp3d hybridization. Yes or no? Yes. Then S comma 3 p orbitals comma 2 d orbitals are combined. You get what? You get sp3d2 hybridization. S comma 3 p orbitals comma 3 d orbitals are combined, you get what? You get sp3d3 hybridization. In this way, so in the inorganic chemistry of the molecules, what I am saying, inorganic chemistry of the molecules, you get different types of the hybridizations. So what are those hybridizations? Sp, sp2, sp3, sp3d, sp3d2, sp3d3, different types of the hybridizations are possible. Yes or no? Yes. Now, I ask about percentage of the S character in these hybrid orbitals. What am I saying? Percentage of the S character in the hybrid orbitals. Say for example, I want percentage of the S character in the sp. Percentage of S character in the sp hybridization is equal. In the sp, how many S orbitals are there? Only one S orbital is there. Sp means what? 2 orbitals. 1 by 2 into 100. That is equal 50% of S character is available. What I am saying? In the sp hybridization, the percentage of the S character I am asking. So, one S orbital is there. Out of the one, 2 hybrid orbitals are there. Sp means what? 2 hybrid orbitals are there. Therefore, 1 by 2 into 100, 50% of S is available. I want percentage of the S in sp2 hybridization. That means what? Here one s orbital is there. sp2 means what? 3 hybrid orbitals are there. sp2 means what? No, no. 3 hybrid orbitals are there. 1 by 3 into 100, that is equal 33.33% of S character is available. Yes or no? For example, I want percentage of the S character in sp3 hybridization. What I am saying? Percentage of the S character in sp3 hybridization. How you get, Nana? One s orbital is there. sp3 means what? 4 hybrid orbitals are there. 1 by 4 into 100, that becomes 25% of the S character is there. In this way, sometimes in the examination ask about questions regarding the percentage of the S character. How you know the percentage of the S character? See, repeat once again. In the sp hybridization, I want percentage of the S. 1 by 2 into 100. That becomes what? 50% of the S character. In sp2 hybridization, percentage of the S character 1 by 3 into 100 sp2. sp2 means what? 1 s orbital, 2 p orbitals. That means what? 1 plus 2. Totally 3 hybrid orbitals are there. I want percentage of the S character 1 by 3 into 100. That becomes 33.33% of S character is there. Very good. And ask about percentage of what? Percentage of the P character, percentage of the S character in the sp3 hybridization. In sp3 means what? 1 s orbital, 3 p orbitals. Only 1 s orbital is there. 1 by 4 into 100. 25% of S character is there in case of sp3 hybridization. And come to the next one, sp3d hybridization. Percentage of S character in sp3d hybridization. Therefore, percentage of S is equal to 1 by 5. You ask the question, sir, why you write 1 by 5? Simple logic. See, totally in sp3d, totally 5 hybrid orbitals are there. What I am saying? 5 hybrid orbitals. I want percentage of the S character. That's why percentage of S character is equal 1 by 5 into 100. That becomes 20% of S character is there in sp3d hybridization. And ask about percentage of the S character in sp3d2 hybridization. Percentage of what? S character in sp3d2 hybridization. Percentage of S is equal to 1 by 6 into 100 and unsimplified you get by 50 by 3. 50 by 3 means what you get, Nana? So that becomes 16.66% of S character is available in sp3d2 hybridization. Very easy concept. And ask about percentage of the S character in sp3d3 hybridization. What I am asking? Percentage of S character in sp3d3 hybridization. Percentage of the S is equal totally. See, Nana, in sp3d3 how many hybrid orbitals are there? 7 hybrid orbitals are there. Out of the 7, only 1 s orbital is there. 1 by 7 into 100. Unsimplified, you get by here how much? 50 by 3.5. Unsimplified, that becomes 500 by 35%. Nearly 14% of S, 14.33% of S character is there. Is one of the shortcut to know the percentage of the S character in the given hybrid orbitals. And we go for the shortcut ways for the calculation of the hybridization methods. Now we go for shortcut method for the calculation of the hybridization. See, what is the shortcut formula I write? Hybridization H is equal group number of central atom. What I am saying? Group number of the central atom, okay, plus number of surrounded monovalent. What I am saying, students? Number of surrounded monovalent. What is the meaning of monovalent? Single bond formation atom plus or minus charge by 2. This is the formula, all the shortcut formula given to you. So this is the shortcut formula for what? Hybridization. Repeat the formula once again. So group number of the central atom, number of surrounding monovalent. What is the meaning of the monovalent? Single bond formation atoms plus or minus charge by 2. So this is the one of the shortcut formula, and go for the examples. So before go for the examples, we take the example of the simple example. SF6 molecule is taken. Tell me what molecule is taken? SF6 molecule is taken. In the SF6 molecule, the central atom is what? The central atom is the sulfur. Therefore, the hybridization H is equal to, see, here sulfur belongs to sixth group. What I am saying, sulfur belongs to sixth group. That's why you write as a 6. The group number is 6. And fluorine always forms monovalent bond, single bond formation, because 6 fluorines are there now. 6 fluorines into 1. Why you take 1? Because except oxygen, all the atoms, you are very well known students, oxygen forms what? Oxygen able to form double bond. But except oxygen, remaining all atoms forms single bonds. Except oxygen, remaining all atoms form single bond. That's why. So here, how many fluorines are there as surrounding atoms? 6 fluorines are there. 6 into 1 by 2. There is no charge. Here in the SF6 molecule, there is no charge. That means what you write? 6 plus 6 by 2. That becomes what? 12 by 2. 12 by 2 means how much you get? Hybridization H is equal to 6. 6 means what? What are the 6 hybrid orbitals? Sp3t2. 1 s orbital, 3 p orbitals, 2 d orbitals. 1 plus 3 plus 2. Totally 6 is there. Totally what I am saying? 6 is there. Very good. That's why. So in F6 molecule, what is the hybridization? The hybridization is Sp3t2. Hybridization is available. Yes or no is one of the important bit. Simple logic, Nana. No confusion about it. So sulfur belongs to which group? Sixth group. Group number is 6. As surrounding oxygen, oxygen always forms what? Oxygen always forms double bond. But fluorine except oxygen, remaining all atoms form single bond. 6 fluorines into 1. That means 6 plus 6 by 2, 12 by 2. 12 by 2 is what? 6. That means hybridization 6 means what? The hybridization is Sp3d2. Simple explanation. And go for the next example. For example, we take xenon difluoride. Next example we explain. Xenon difluoride. In the xenon difluoride, you are very well known. Xenon belongs to a noble gas. Is a 8th group element. What am I saying? It is the 8th group element. That's why xenon belongs to the 8th group. And you are very well known. 2 fluorines are there. So fluorine forms single bond or double bond. Fluorine able to form single bond. That's why you write fluorine 2 into 1. So by 2. That means what you write down here? 8 plus 2 by 2. 8 plus 2 by 2 means what? 10 by 2. 10 by 2 is equal to how much? 5. That means hybridization 5 means what? Participation of the 5 hybrid orbitals. That means 1s, 3p, 1d. So this is the hybridization of the xenon difluoride. The xenon belongs to Sp3t hybridization. Simple explanation, no confusion at all. Very, very simple explanation. And take the example of xenon hexafluoride. What I am saying? Xenon hexafluoride. In the xenon hexafluoride, you are very well known. The xenon group number is 8 group. It is the 8 group element. Very good. So 8. And you are very well known. Fluorine, how many fluorines are there? 6 fluorines. Each fluorine able to form single bond or double bond? Single bond. In the formula, monovalent atoms are there. In the formula, what is there? Monovalent atoms are there. That means 6 into 1. So what you write here, Nana? That means what you write here. So 8 plus 6. 8 plus 6 by 2. That becomes 14 by 2. 14 by 2 means what? 7. 7 means what is the hybridization? The hybridization is Sp3t3 is available. What is the hybridization is available? Sp3t3 is available. A simple explanation. No confusion about the explanation. Very easy. And go for the next example. Xenon tetrafluoride. What I am saying, Nana? Next example. Xenon tetrafluoride. Regarding the xenon tetrafluoride, the hybridization H is equal. Xenon again noble gas 8th group. So group number. Take the group number of the central atom. Xenon belongs to 8th group. Very good. Plus, how many fluorines are there? 4 fluorines are there. Fluorine always forms single bond monovalent atoms by 2. That means what you write? 12 by 2. 12 by 2 means what? 6. 6 means what is the hybridization? 6 means participation of the 6 hybrid orbitals. Sp3d2 hybridization is available. What is available? Sp3d2 hybridization is available. Is one of the easiest shortcut. And go for the next shortcut way. It's very easy, Nana. So what is the simple formula? Group number of the central atom plus number of surrounding monovalent atoms plus or minus charge by 2. In XCF2, in XCF4, in XCF6, there is no charge. That's why you get the hybridations like this. And one more beautiful important point is there. regarding the Jinan compounds. What is the one more beautiful point is there regarding the Jinan compounds? This is a very important objective theory bit. So Jinan difluoride exists as a solid, and the Jinan tetrafluoride exists as a solid, and the Jinan hexafluoride exists as a solid. So all these solids are examples of the sublimating nature, one of the excellent Vignana. All the solids are examples of sublimating solids. You are very well known. So what are the examples of the sublimating solids? Sublimating solids means what? The solid on heating directly goes to the vapor state without getting of the liquid state. That is the meaning of the sublimating solids. So the solids are stable up to room temperature. So at 25 degrees only they are stable. One of the excellent bit is given 3 years back in EAMCET examination. One of the beautiful bit. So Jinan difluoride, Jinan tetrafluoride, Jinan hexafluoride are examples of what? Sublimating solids. What are the meaning of the sublimating solids? The solids on heating directly goes to the what state? Vapor state without getting out the liquid is one of the beautiful point. The solids are stable up to the room temperature. Beyond room temperature, they are not stable. What I am saying? Beyond room temperature, they are not stable. That's why these Jinan difluoride, tetrafluoride, hexafluorides are used as what? Fluorinating agents. One of the beautiful point. What I am saying? They are used as fluorinating agents. What is the meaning of the fluorinating agents? The agents which supplies the fluorine to the given species. What I am saying? The agents are used as fluorinating agents. Fluorinating agents means what? The agents which readily supplies the fluorine to the given species. They acts as one of the best fluorinating agents, one of the important way. And now we explain the example of what? Example of the oxygen as the surrounding atom. Up to here we discuss about monovalent atoms are completed. Now we discuss about oxygen as the surrounding atom. Now see that oxygen as the surrounding atom. Say for example, you take the example of xenon trioxide, and you take the example of xenon tetroxide, and you take the example of xenon oxy tetrafluoride. In these three species we have to find out the hybridization. What I am saying, brothers, in the species we take the example of the hybridization. See, as oxygen as the surrounding atom, you are very well known, oxygen belongs to the sixth group element. So because of the sixth group element, to get octet, it able to form double bond. That means oxygen as surrounding atom, it able to form a double bond to get octet. To get what, brother? Octet. That's why. So what is the formula for the hybridization here? H is equal. I find out hybridization xenon trioxide. H is equal. Xenon belongs to the 8th group plus 3 into oxygen taken as divalent. Because of divalent taken as 0, one of the beautiful point. Because of divalent taken as 0. Because in our formula what is there? In our formula monovalent is there. That's why 3 into 0 by 2. That means what you write? You write 8 by 2. 8 by 2 is equal to 4. Now what is the hybridization? The hybridization 4 means what? 4 hybrid orbitals are participated. The hybridization is what? Sp3. What is the hybridization? Sp3 hybridization is possible. Okay, see Nana. So Himakar C, Sp3d5 is not possible. Why Sp3d5 is not possible? Because oxygen is divalent. Oxygen divalent means what? It forms a double bond. But you know, formula what is there? Monovalent is there. That's why that type of hybridization is not possible. The maximum hybridization is Sp3d3 Nana. But what you said, so Sp3d5F7, that type of the molecules are not discovered. Himakar C, that type of the molecules are not discovered. Sp3d5F7. So just as for funny you write like that. But if that is not correct, Nana. So the maximum hybridization is Sp3d3. Beyond Sp3d3, the hybridization is not possible. Learn the point properly. And come to xenon tetroxide. Hybridization H is equal. So xenon is what? 8th group, because the group number of central atom is 8th group, and you are very well known. Oxygen able to form double bond. What I am saying? Oxygen able to form what? Double bond. That's why 4 into 0 you write. Why you write 4 into 0? Because of able to form double bond. But in formula single bonds formation is there. That means 8 by 2. 8 by 2 means what? 4. The hybridization is 4. What is the formula? So H is equal to 4. That is hybridization. H is equal to 4. That is what? Sp3 hybridization is possible. Himakar, thank you. So the type of hybridization is not possible for your responding. Okay, right. And xenon oxy tetrafluoride hybridization H is equal. See, xenon is what? 8 group. Here, oxygen has the surrounding atom 1 into 0 because aldehyde said. What aldehyde said? Oxygen able to form double bond. But in our formula, what is there? Monovalent single bond formation is there. Plus 4 into 1 because fluorine forms single bond. That means what you write, brother? So 8 plus 4. 8 plus 4 means what? 12 by 2. 12 by 2 means what? 6. Now what is the hybridization? Sp3t is possible. In xenon oxy tetrafluoride, what I am saying? Xenon oxy tetrafluoride Sp3t hybridization is possible like this. So in the neutral molecules, we have to find out hybridization like this and go for the next example. See, in xenon oxy tetrafluoride, what is the hybridization? Sp3t hybridization is possible. And go for the next example. For example, this example is there in your second year. Xenon dioxide difluoride solid. In xenon dioxide difluoride solid, so what type of hybridization is possible? In xenon dioxide difluoride solid, the hybridization possible. Hybridization H is equal. See, xenon is a central atom. Its group number is 8. What I am saying? Its group number is 8. As oxygen has surrounding atom, so oxygen always forms double bond. That's why taken as 2 into 0. Taken as what? 2 into 0 plus, here how many fluorine atoms are there? 2 fluorine atoms. Fluorine always forms able to form single bond or double bond. Fluorine always able to form single bond 2 into 1. So that means by 2. Now what you write? Students. So 8 plus 2 by 2. That becomes 10 by 2. 10 by 2 means 5. 5 means what? So participation of the 5 hybrid atoms, that becomes what? Sp3 dehybridization is possible. In this way, by using the shortcut formula, you get all types of the hybridations. And we'll go for the next example. Sulfur dioxide gas and the sulfur trioxide gas. You are very well known. In the sulfur dioxide, so sulfur group number hybridization H is equal. Sulfur belongs to which group, Nana? Sulfur belongs to the sister group of element. Sister group. Which one sister group? Oxygen, sulfur, selenium, tellurium, polonium are examples of the what? Sister group of the elements. The hybridization H is equal. Sulfur belongs to what? Sister group. 6 plus oxygen able to form what? Double bond. 2 into 0. So by 2. That means what you write? 6 by 2. 6 by 2 is equal to 3. Therefore, if the hybridization is 3, what is the hybridization here? Sp2 hybridization is available because of the 3 participation of the 3 hybrid atoms. Come to the SO3. Hybridization H is equal. Sulfur belongs to the sister group plus 3 into how many oxygens are there? 3 oxygens are there. Oxygen able to form double bond. That's why taken as 0. So by 2. That means 6 by 2. 6 by 2 means what? 3. So what is the hybridization? The hybridization is what? Sp2. What you are asking, Nana? So Lakshmi, Chandan Lakshmi, oxygen family, na? So but sulfur is a central atom. Sulfur central atom means what? Central atom group number is 6. But oxygen is taken as what? 0. Why oxygen taken as 0? What is the formula? Group number of the central atom. What I am saying? Group number of the central atom and plus number of surrounding monovalent atom. But oxygen is able to form divalent, Nana. Oxygen is sister group element. It is able to form double bond. Oxygen is what? Chandan Lakshmi. Oxygen able to form what? Double bond. But in our formula, what is there? In our formula, monovalent atoms are there. That's right. Sulfur is central atom taken as group number 6, Nana. But oxygen taken as what? In our formula, number of surrounding monovalent. Monovalent means number of surrounding monovalent means single bond formation. But oxygen is a divalent. Because why oxygen is divalent? Sister group means it has 6 electrons to get octet. So able to form double bond. Able to form what, Nana? Double bond. That is the reason. Now it is clear? Yes. That's why in case of oxygen surrounding 3 into 0 is taken. That's why the hybridization is Sp2. One of the beautiful point. Very good, Nana Lakshmi. And go to the next example. When go to the next example, Nana, one more best example is taken. Say H2O molecule. Now see, in the H2O liquid, who is the central atom? Oxygen is the central atom. As oxygen is the central atom, hybridization H is equal. So the group number of oxygen, because oxygen is a central atom, the group number is taken as 6. Okay. Next, number of surrounding monovalent atoms. Here, how many hydrogens are there? Two hydrogens are there. What I am saying? Two hydrogens are there. 2 into 1, because hydrogen always forms single bond. Why hydrogen always forms single bond? Because of the 1A group. Okay, that means what you write? 6 plus 2 by 2, 8 by 2. 8 by 2 means what you write? 4. 4 means hybridization is Sp3. What is the hybridization, Anna? The hybridization is Sp3. Take the one more example, ammonia liquid. In case of the ammonia liquid, who is the central atom? So central atom is what? Nitrogen. Nitrogen belongs to fifth group because you are very well known. Nitrogen family, picogen family. Nitrogen, phosphorus, arsenic, antimony, bismuth. So nitrogen is a fifth group element, 5. Plus, how many hydrogens are there? 3 hydrogens are there into 1. Okay, so 5 plus 3 by 2. That means what you write, Nana? 8 by 2. 8 by 2 means what? 4. 4 means the hybridization is what again? Sp3. Yes or no? Yes, very good. And take the example, so many examples like this. Okay. And now we discuss about anionic species and cationic species. That is very, very important in the examination point of view. So I am discuss about cationic species. So up to here, the neutral molecules are completed. Up to here, what is completed? Neutral molecules are completed. Now we discuss about the cationic species and anionic species. Come to the cationic species and anionic species. Take the example of CH3 plus ion. What is the meaning of CH3 plus ion? This is called methyl carbonium ion. Tell me the name. Methyl carbonium ion. The name of the CH3 plus is an organic species, carbocation. Methyl carbonium ion. Okay, we have to find out hybridization in the methyl carbonium ion. Now, how you find out the hybridization in methyl carbonium ion? Simple explanation, Anna. Hybridization H is equal. Who is the central atom? Carbon is the central atom. In the methyl carbonium ion, who is the central atom? Carbon is the central atom. So what is the group number? The group number is 4 because carbon is a fourth group element. How many hydrogens are there? 3 hydrogens are there. What I am saying? 3 hydrogens are there. Okay, don't worry, I am explaining. Abhiram, so what if CH4? Don't worry, I am explaining. Don't worry, listen carefully. So 3 hydrogens are there. Here what charge is there? Positive charge is there. Positive charge means what? So subtract in the formula. So group number of central atom is 4. Number of surrounding monovalent atoms plus or minus charge. A plus 1 charge is there taken as minus 1. Positive is there subtracted by 2. As the formula that becomes 6 by 2. 6 by 2 is equal to 3. So hybridization 3 means what? The hybridization is Sp2. Hybridization 3 means what, Nana? The hybridization is Sp2. How you know the hybridization is Sp2? Because of positive charge is there plus 1 subtraction of the minus 1 in the formula. Okay, okay, right. And take the example of CH3 minus ion. CH3 minus ion is called methyl carbanion. What I am saying? Methyl carbanion is called what? Methyl carbanion is called CH3 minus ion. These bits are very, very important, already given on in the previous papers. So these cationic species or anionic species are bits already given in the previous papers. Okay, CH3 minus ion is called methyl carbanion. Now what is the formula? Hybridization H is equal. So carbon is the group number is fourth group. How many hydrogens are there? 3 hydrogens are there. Yes or no? So in methyl carbanion, so the carbon belongs to fourth group now. Very good. 4. How many hydrogens are there? 3 hydrogens are there. Here minus means what? Adding of the plus 1. Very good. So Abhiram, very good. The answer is Sp3. Nice. Very good. So minus 1 means what? Adding of the plus 1 charge by 2. That means 8 by 2. 8 by 2 is equal to 4. What is the hybridization? The hybridization is Sp3. As you said, Abhiram, very good. So this is the one of the shortcut formula in case of the cationic species, in case of the anionic species. Very good, very good. And go for the next example. See, in CH3 plus, because of positive charge, in the formula subtraction of the minus 1. In the CH3 minus 1 ion, minus means what? Adding of the plus 1. Okay, and go for the next example. When go for the next example, regarding the next example, see, the next example of the cationic species, next example of the anionic species are given. Regarding the next example of the anionic species are given phosphate ion. This is called orthophosphate ion. Next example is given as sulfate ion. Next example is given as nitrate ion. See, so 3 anions are given. Tell me now what given? 3 anions are given. So what are the 3 anions are given? So one is called phosphate anion, next one is called sulfate anion, next one is called nitrate anion. What I am saying? Yeah, don't worry. So, Sai Kumar, I'm also explaining the bond length. Our completion of this anionic species and cationic species, I'm explaining the bond length also. Don't worry about the bond length. Our completion of these 3 points. So, phosphate anion, sulfate anion, nitrate anion, I'm also explaining the bond lengths. Okay, Nana, Sai Kumar, very good. Come to the phosphate anion. So, hybridization H is equal. Phosphorus belongs to which group? Phosphorus belongs to fifth group. Very good. 5. And oxygen is a surrounding atom that is taken as divalent. Because of the divalent, in the formula, surrounded monovalent. Monovalent means single bond formation. Therefore, 4 into 0 is taken. Plus, what charge is there? Minus 3 charge is there. What charge is there? Minus 3 means adding of the plus 3. Therefore, 5 plus 3 by 2. 5 plus 3 means what? 8 by 2. 8 by 2 means 4. What is the hybridization? The hybridization is Sp3. What is the hybridization, Anna? The hybridization is Sp3. Simple explanation, brother. No confusion. So, this anionic species and cationic species in the examination very important. Already given in the previous EAMCET papers. This type of questions already given in the previous MCQ papers, Nana. Okay, right? Right, very good. So in the phosphate anion, what is the hybridization? Sp3. How you know, brother? So phosphorus is 55. Oxygen is divalent. What I am saying? Oxygen is divalent 4 into 0. What is the charge of the phosphate? Minus 3. Minus 3 means adding of the plus 3 by 2. 8 by 2. 8 by 2 means what? 4. The hybridization is Sp3. What is the hybridization? Sp3. Come to the sulfate anion. In case of the sulfate anion, sulfur belongs to what? Sulfur belongs to sixth group, 6. Very good. Okay, Nana. And see, oxygen as surrounding atom, 4 into 0 taken. Why you taken 4 into 0? All I said. Oxygen is a divalent atom. Sixth group element means 6 electrons are there. Sixth group element means 6 electrons are there. To get octet, it able to form double bond. But in our hybridization formula, monovalent single bond atoms are there. As surrounding, monovalent required. But here oxygen is divalent. That's why taken as 0. Minus 2 means adding of the 2 by 2. That means what you write, Nana? 8 by 2. 8 by 2 means what, Nana? 4. Therefore, the hybridization is Sp3 because of the. So, 4 value is there. Participation of the 4 hybrid orbitals. See, Abhiram, bivalent. As per our shortcut formula of hybridization, group number, see the shortcut formula, Abhiram, group number of the central atom plus number of surrounding monovalent. What is monovalent, Abhiram? Single bond formation. Monovalent means what? Single bond formation, but oxygen is divalent. That's why divalent is there, taken at 0. Don't forget that. Because oxygen is divalent. Why oxygen is divalent? Because of sister group element. To get octet, it able to form double bond. It don't form single bond. That's why in case of oxygen surrounding taken at 0, Nana, Abhiram. Right, Nana? And next one, nitrate ion. Come to nitrate ion. Nitrogen belongs to which group? Fifth group. 5. Very good. See, plus 3 into. Oxygen is example of divalent. Why oxygen is example of the divalent? Because oxygen is a sister group element. That's why divalent element taken at 0. Minus means adding of the 1. That means 5 plus 1 by 2. 5 plus 1 by 2 means what? 6 by 2. 6 by 2 means 3. What is the hybridization? The hybridization is Sp2. That means in the nitrate ion, what I am saying, in the nitrate ion, the hybridization is what? In the nitrate ion, the hybridization is Sp2, one of the beautiful bit. In case of these, what? In case of these anions, see, Nana, in the phosphate anion, hybridization is Sp3. In the sulfate anion, hybridization is Sp3. In the nitrate anion, hybridization is what? Sp2. Very good. So, right. And we discuss the double bonds later. Our completion of this. Very good, Nana. Now we discuss about so effect of the bond length by the hybridization. What I am saying? Effect of the bond length by the hybridization. Before saying the effect of the bond length by the hybridization, you know one important word. See, for example, I will give one simple example to you. See the example of the ethane gas. Abhiram, see the effect of the bond lengths, Nana. Abhiram, see the effect of bond lengths. So this is the example of the ethane. Actually, in case of the organic molecule, see example of this is what? Ethene. Okay. and take the example of the ethane. So in case of the organic molecules, how you find out the hybridization? Before saying of the hybridization in the organic molecules, see, in hybridization, hybrid orbitals are head-on overlapping. As hybrid orbitals are head-on overlapping, what am I saying, Nana? As hybrid orbitals are what? Head-on overlapping always forms sigma bond. Therefore, in a hybridization, sigma bonded electrons are counted. What I am saying? Sigma bond electrons are counted in the hybridization process. Remember this point. In case of organic molecules, in hybridization, sigma bonded electrons are counted. What am I saying in the organic molecules? In the organic molecules, in hybridization, hybrid orbitals are head-on overlapping. Because of head-on overlapping, sigma bond electrons are counting because hybrid orbitals form sigma bonds. Now see, take this carbon, Nana. In this carbon, how many sigma bonds are there? What I am saying? So, head-on overlapping means what, Nana? Abhiram, head-on overlapping means sigma bond. Head-on overlapping means nucleus to nucleus overlapping. Nucleus to nucleus overlapping means head-on overlapping. The head-on overlapping means sigma bond. Head-on overlapping means what, Nana? Sigma bond. Very good. So this carbon has how many sigma bonds? One single bond is always sigma bond. One sigma bond, second sigma bond, third sigma bond, fourth sigma bond. Therefore, this carbon has how many sigma bonds? Four sigma bonds are there. Four sigma bond means what, Nana? 8 electrons are there. 8 electrons are there. Hybridization is Sp3. How you know hybridization is Sp3? S orbital having 2 electrons, Px having 2, Py having 2, Pz having 2 electrons. What I am saying? 4 sigma bonds means what? 8 electrons. 8 electrons means what, Nana? S orbital accommodate 2 electrons. Px accommodate 2 electrons. Py accommodate 2 electrons. Pz accommodate 2 electrons. That's why 4 sigma bonds means 8 electrons. Now take this carbon. This carbon means what? Single bond is sigma bond. Single bond is sigma bond. This single bond is sigma bond. This single bond is sigma bond. Therefore, here also 4 sigma bonds are there. 4 sigma bonds means what, Nana? 8 electrons are there. 8 electrons means what is the hybridization? Sp3. That means if carbon has 4 sigma bonds, what is the hybridization? The hybridization is Sp3. Is one of the important bit in the organic molecules. Repeat the bit once again. In the organic molecules, the carbon have the 4 sigma bonds. 4 sigma bonds means what? 8 electrons, the hybridization is Sp3. Come to this example, ethene example. Come to what example, Nana? Ethene example. In case of the ethene example, see the example of the ethene. So this is very, very important. Before explanation of the bond lengths, the examples are very, very important. In case of this ethene example, see, as I said, hybrid orbitals are head-on overlapping always forms sigma bonds. But pi bond is not counting in hybridization. What I am saying, Nana? Pi bond. You are very well known, brothers. Double bond means what? One is a sigma bond and one is a pi bond. Double bond means what? One sigma bond, one pi bond. In hybridization, pi bond is not counting. What I am saying? In hybridization, pi bond is not counting. Only sigma bonds are counting. In the double bond, one is a sigma bond. Single bond is always a sigma bond. Single bond is always a sigma bond. That means this carbon has how many sigma bonds are there? 3 sigma bonds are there. 3 sigma bonds means what? 6 electrons. 6 electrons means what is the hybridization? Sp2. Therefore, in the ethene molecule, doubly bonded carbon is, in the ethene molecule, doubly bonded carbon is Sp2. Come to here, a sigma bond. Single bond is a sigma bond. Single bond is a sigma bond. Single bond is sigma bond. So 3 sigma bonds are there. 3 sigma bonds means what? 6 electrons. Therefore, hybridization is what? Sp2. That means if carbon surrounded by 3 sigma bonds, that is Sp2 carbon. What I am saying? The carbon surrounded by 3 sigma bonds, that is what carbon? Sp2 carbon. Very, very important point. So, in the hybridization process, the pi bonds are not counting. Why the pi bonds are not counting? Because the pi bond is a sidewise overlapping. What I am saying? Pi bond is what overlapping? Sidewise overlapping. As pi bond is sidewise overlapping, it is not involved in the overlapping. Therefore, the sigma bonds are involved in the overlapping. What I am saying? Sigma bonds are involving in the overlapping. Therefore, in the ethene, the hybridization is sp2. Okay, Nana? And come to the ethane. Come to what? Ethane. Take the example of the ethane. Ethane is also called acetylene. Ethane is also called what, brother? Acetylene. So this is the other name of the ethane molecule. Now see, triple bond is there. What I am saying? Triple bond is there. Triple bond means what? So you are very well known. So the middle one is a sigma bond. Above one is a pi bond. Below one is a pi bond. As I said, single bond is always a sigma bond. Single bond is always a what bond? Sigma bond. Therefore, in hybridization we count only sigma bonds. Why in hybridization we count only sigma bonds? Because sigma bonds are head-on overlapping. Hybrid orbitals are head-on overlapping form sigma bond nana. Therefore, it's a single bond sigma bond, single bond sigma bond. Two sigma bonds are there. Two sigma bonds means what? Four electrons are there. That is equal to hybridization is sp hybridization is available. So this carbon has two sigma bonds. Here, what is the hybridization? The hybridization is sp possible. Therefore, two sigma bonds are there. The hybridization is sp. Three sigma bonds are there. The hybridization is sp2. Four sigma bonds are there. The hybridization is what? sp3. Therefore, in the organic molecules, what I am saying, in the organic molecules, what is the hybridization is possible? In the organic molecules, the hybridization sp3, sp2, sp possible, sp3d is not possible. This is one of the important points. In organic molecules, see Nana, one of the excellent point in organic molecules, which of the following hybridization is not possible? Which of the following hybridization not possible? In organic molecules, which of the following hybridization is not possible? The first option given as sp3, the second option given as sp2, the third option given as sp, the fourth option given as sp3d. See the one of the beautiful question. In organic molecules, which of the following hybridization is not possible? Tell me your answer. See what I am saying? In organic molecules, which of the following hybridization is not possible? sp3, sp2, sp, sp3t. Tell me answer. Please, anyone chart, tell me the answer, Nana. So, which of the following hybridization is not possible? See, the answer is sp3d not possible. Why sp3d is not possible? Very good. Nana Lakshmi, very good. Why sp3d is not possible? The simple reason, Nana, because of in the carbon, d orbital is absent. Carbon atomic number is 6. That means what you write? Helium 2s1, 2px1, 2py1, 2pz1. Yes or no? So in the carbon, so the d orbital is absent because of absence of the d orbital. Because of what, Nana? Absence of the d orbital. Therefore, sp3d hybridization is not possible. One of the excellent, beautiful way. So in the alkanes, sp3 is possible. In the alkenes, sp2 is possible. In the alkynes, sp is possible. What I am saying? In the alkanes, sp3 is possible. In the alkenes, sp2 is possible. In the alkynes, sp is possible. But in the organic molecules, sp3d is not possible because of absence of the d orbital. Now go to the bond lengths. Now we discuss about the concept of the bond lengths. The concept of the bond lengths are very, very, very important. Take the example of the alkane. In the alkane, CC single bond is available. In the alkene, CC double bond is available. In the alkyne, CC triple bond is available. These bond lengths are also very, very important in the examination point of view. Some bits are given on the concept of these bond lengths. Repeat once again. In the alkanes, single bond is there. You are very well known. In the alkane, the hybridization is sp3. In the alkene, the hybridization is sp2. In the alkyne, the hybridization is sp. Yes or no? So these are the hybridations are available in the alkanes, alkenes, alkynes. Now go to the bond length. So this is a CC single bond. Because of CC single bond, the bond length is 1.54 angstroms. Because of CC single bond. In case of the CC double bond, the bond length is 1.34 angstroms. Because of CC triple bond, the bond length is 1.20 angstroms. One of the excellent bit nana. Regarding the bond lengths, CC single bond length is 1.54 angstroms. CC double bond length is what? CC double bond length is 1.34 angstroms. Okay, 1.34 angstroms. CC triple bond length is what? 1.20 angstroms. That means what I am saying, as percentage of S character increases, what I am saying, as percentage of the S character increases, yes, yeah, I was saying correct. In case of the picometers 154, the value in terms of angstroms, that is same value. Because you very well know, Lakshmi, 1 angstrom is equal to 100 picometers. This is the conversion, Anna. 1 angstrom is equal to how much? 1 angstrom is equal to 100 picometers. That's why 154 picometers, 134, 130, not 130, Nana. 134 picometers, 120 picometers, both have same value. I am writing in terms of angstroms. Therefore, percentage of S character increases, so the bond length value decreases. One of the beautiful point. What I am saying, as percentage of the S character increases, bond length value what happens? Decreases. This is one of the beautiful point. Repeat the point once again. As percentage of the S character increases, the bond length value what happens? Decreases. One of the beautiful point. How you know is a beautiful point. In case of the sp hybridization, the percentage of the S character is 50% of the S character. In case of the sp2, percentage of the S character is 33.33% of the S character is there. In case of the sp3, percentage of the S character is what? 25% of S character is there. In case of sp hybridization, percentage of the S character is more, therefore the bond length is less. What I am saying? As percentage of the S character is more, the bond length is less. In case of sp3, the percentage of the S character is less, the bond length value is more. It's one of the beautiful points. Therefore, as percentage of the S character increases, bond length increases, bond length decreases. And see the next important point. The next important point is, see, as bond length is inversely proportional to bond energy. What I am saying? The bond length is inversely proportional to bond energy. Therefore, so the bond length is less in alkynes. In bond length is less in alkynes, therefore the bond energy is more for alkyne. Because of triple bond, the bond energy is more. Because bond length is inversely proportional to bond energy. What I am saying, Nana? Bond length is inversely proportional to bond energy. Therefore, in the alkynes, the bond length is less. That's why bond energy is more. One of the beautiful point. Yes or no? What I am saying, Emma? Yes or no? So the bond length is less in alkynes. The bond length is less in the alkane. Therefore, the bond energy is more value. Very nice point. And go to the next important point. See, Nana, is one of the beautiful important point. Now go for the next beautiful important point. And next for the regarding the important point here. So what is the bond order? This is the one of the excellent point. What is the bond order value? This value not there in the books, and listen carefully. Bond order value in alkanes. Okay. Bond order value in alkenes. Bond order value in alkynes. What I am asking? Bond order value in alkanes, bond order value in alkenes, bond order value in alkynes. This is the one of the beautiful point. First of all, what is the bond order? Bond order means what? The bond order, yes. Because see, Lakshmi, if the benzene the CC bond is 139 picometers, that is correct. Why? Because of the conjugation property. See, this is a benzene molecule. See, this is a benzene. So benzene, first of all, what is conjugation? Double bond separate by single bond. This is called a conjugation property. Yes or no? See, what I am saying, double bond separate by single bond is a conjugation. Double bond separate by single bond is a conjugation. Double bond separate by single bond is a conjugation. Because of this conjugation property, the pi bond electrons are delocalized. What I am saying, pi bonded electrons. The pi bonded electrons are delocalized. What I am saying? The pi bond electrons are delocalized. At delocalization of pi bond electrons, so the bond length becomes what? 1.39 angstroms. That is the one of the important beautiful bit. The reason is pi bonded electrons are delocalized. What is the reason there? Because the pi bond electrons are what? Nana? Delocalization happens. Because of the pi bonded electrons are delocalization happens, the bond length is what? 1.39 angstroms. Why the bond length is 1.39 angstroms? I give the reason. So it's a single bond. The CC single bond length is what? 1.54 angstroms. CC double bond length is what? CC double bond length is 1.34 angstroms. But here the pi bonds are delocalized now. Because the pi bonds are delocalized, the bond length is in between the single bond comma double bond length. The bond length is what, Nana? In between the single bond comma double bond length because of the conjugation property. What is the reason there? Because of what property? Because of the conjugation property. CC single bond length is what? C single bond length is 1.54. CC double bond length is what? 1.34 angstroms. So because of this conjugation property, so that is less than single bond and more than double bond. What I am saying? Because of what, Nana? Conjugation property. What is conjugation? Pi bond electrons are delocalized. Because of the pi bond electrons are delocalized. What is the meaning of delocalization? The pi electrons are revolving in the ring structure. Pi bond electrons are revolving in the ring structure. That's why the bond length is equalized. That becomes 1.39 angstroms. One of the beautiful bit. Now, on this, I will frame one question. See, Nana, on the benzene, I will frame one important question. That question is given in the previous JEE mains paper. How the question is given in the examination. Now, see, a benzene molecule is given like this, Nana. So, it's a benzene molecule. This is a CC single bond taken as X angstroms. So, this is a CC double bond taken as what, Nana? Y angstroms. So, which of the following correct? Which of the following correct regards bond length in benzene nucleus, bond length in benzene molecule is the one of the good question. What I am saying, which of the following correct regarding bond length in the benzene nucleus? The first option is given as x greater than y, second option given as x less than y, third option given as x is equal to y, fourth option is given as none of this. See, Nana, one of the beautiful question is given in the previous JEE mains paper. See the question. So, in the benzene nucleus, single bond length given as x angstroms, double bond length given as y angstroms. Which are the following correct regarding bond length? BL means what? BL means bond length in the benzene molecule. The first option given as x greater than y, second option given as x less than y, and third option given as x is equal to y. Fourth option is none of this. Tell me your answer, Nana. Tell me, please think your answer. I will give just 30 seconds time. 30 seconds time I given. Please tell me. What is your answer now? X less than y, x greater than x is greater than y, x less than y, x is equal to y. None of this. Answer is x is equal to y. You ask the question. Why, sir? Answer is x is equal to y. Yes, I give the explanation. Because of what? So because of the pi bond electrons are in the conjugation property. What I am saying, Nana? Pi bond electrons are in conjugation. See, double bond separate by single bond conjugation. Double bond separate by single bond conjugation. Yes, double bond separate by single bond conjugation. Because of conjugation property. Where you have a conjugation property, what am I saying? Where you have a conjugation property, the bond lengths are equalized. What I am saying, Nana? Where you have a conjugation property, the bond lengths are equalized. That's why x is equal to y. I will give one more bit like this. I will give one more bit like this, Nana. See, this bit also given in the previous examination paper. Take the example of the ozone molecule. Example of what, brother? Ozone. See the example of the ozone molecule. You know ozone available in the stratosphere as a protective layer. Yes or no? So this is a ozone structure of the ozone molecule. Yes or no? See, in the structure of this ozone molecule, So this is called O comma O single bond X angstroms, O comma O double bond Y angstroms. Which of the following correct? Which of the following correct regards bond length in the ozone gas? Regarding bond length in the ozone gas. The first option X greater than Y. Second option X less than Y. Third option X is equal to Y. Fourth option none of these. So the options are given like this now. See, the options are given like this. Okay, see, this is a ozone gas. Again, here the answer is X is equal to Y. What I am saying, Nana? So this is a ozone molecule. So the structure of the ozone in the examination, structure of ozone given like that. Which of the following is correct regarding bond length in the ozone? Now see what are the options given? X greater than Y first option, X less than Y second option, X is equal to Y, and next one is what? None of this. Tell me your answer, Nana. The answer again, the answer is third option. Very good. Why? Because of conjugation property. Simple logic, brother. Where you have a conjugation property, the bond lengths are equalized. Sachinarana, very good. Okay, Abhi was Varsha, very good. So because of the bond lengths are equal. Why the bond lengths are equal? See, lone pair double bond separated by a single bond, that is a conjugation. Lone pair double bond separated by a single bond is a conjugation property is there. So because of the conjugation property, X is equal to Y. Not only here, where we have a conjugation property, X is equal to Y. That's why the bond length is 129. Very good. I will ask this correct. The exact value is 129 picometers. Very good, Nana Lakshmi. The exact answer is 129 picometers. But in the examinations, don't ask about exact values. Don't worry about the exact values. The bits are given like that. Very good. Now, first of all, what is the meaning of conjugation? First, I discuss about what is the meaning of the conjugation? In the given molecule, how the conjugation is checked out. See, double bond separated by single bond is called double bond conjugation. What I am saying, Nana? Double bond separated by single bond is called what, Nana? Double bond conjugation. One of the important point. See next one. Lone pair double bond separated by single bond is called lone pair conjugation. What I am saying? Lone pair conjugation. Very good. Positive charge double bond separated by a single bond is called positive charge conjugation. What property? Positive charge conjugation. Very good. And next one. Negative charge double bond separated by a single bond is called negative charge conjugation. What I am saying? Negative charge conjugation. And next one. A radical and double bond separated by single bond is called radical conjugation. What I am saying? Radical and double bond separated by single bond is called radical conjugation. So this is a phenomena of a conjugation property. What I am saying is a phenomena of what? Is a phenomena of the conjugation property. Conjugation is also called resonance. The resonance is also called mesomerism. Sinana. So resonance also called what? Mesomerism. Mesomerism also called what? Conjugation. Okay. And this is also called what? Robinson effect. What I am saying? Robinson Ingold effect. Conjugation also called. What is the other name of the conjugation? Robinson Ingold effect. Simple logic, Nana. What is simple logic, Nana? Double bond separated by a single bond, or lone pair double bond separated by a single bond is called lone pair conjugation. Positive charge double bond separated by a single bond is called positive charge conjugation. Okay. Negative charge double bond separated by a single bond is called negative charge conjugation. Or the radical and double bond separated by a single bond is called radical conjugation. That is called conjugation or resonance or mesomerism or Robinson Ingold effect. The effect is called Robinson Ingold discovered, invented the effect. That's why this is called Robinson Ingold effect. So that's why in the molecule where we have a conjugation property, the bond lengths are always equalized. The bond lengths are always what, Nana? Equalized. Very good. Take this example, for example, Nana. C double bond O Okay, O minus, okay, O minus, lone pair is like that is there. Okay, lone pair is like this. So this is a lone pair like this. This is called carbonate ion. CO3 minus 2 ion. It's called carbonate ion. It's called what ion, Anna? Carbonate ion. Here also you check out. So here this is taken as X angstroms, okay, and this is taken as Y angstroms. Which of the following is correct regarding CO bond length? Which of the following correct regards? Which of the following correct regards CO bond length? Which of the following correct regarding CO bond lengths? Again, the answer is X is equal to Y is the correct answer. Simple logic, Nana. Simple logic. X is equal to Y is the correct answer. Why the answer is X is equal to Y? Because the conjugation property. What I am saying? That is called CO3 minus 2 ion. CO3 minus 2 ion is called what? Carbonate ion. What I am saying? Carbonate ion. In this carbonate ion, which of the following is correct regarding CO bond length? The answer is X is equal to Y once again because of the conjugation property. What I am saying, brother? Because of conjugation. How you know is the conjugation? See, negative charge double bond separated by single bond. Negative charge conjugation. Negative charge double bond separated by single bond is called a negative charge conjugation. That's why the answer is X is equal to Y. That's why repeat once again, where you have a conjugation property, where you have a mesomerism property, where you have a conjugation property, where you have a mesomerism property, so there the bond lengths must be equalized. And go to the next part. Regarding the next part, we discuss about how the bond angles are affected. What I am saying, Nana, how the bond angles are affected. See, one important bit is given. See, limestone. You know limestone. CaCO3 solid is a limestone. Limestone unheated to temperature of 1024 degrees forms what? Forms calcium oxide solid plus CO2 gas. This is the question given in the previous JEE mains paper. See this question, Nana. Limestone. You know very well. What is limestone? CaCO3 is called limestone. Limestone heated to temperature of what? 1024 degrees gives rise to what? CaO solid plus CO2 gas. Yes or no? So limestone on heating. What I am saying? Limestone on heating. See the question given. The hybridization of carbon is one of the beautiful questions given in the 4 years back mains paper. The hybridization of the carbon changed from dash to dash. Changed from the hybridization of carbon changed from dash to dash. One of the beautiful bit. See the first option given as Sp2 to Sp. The second option given as Sp3 to Sp2. The third option given as Sp2 Sp2, and the fourth option given as Sp3 to Sp. This is the question given like that. One of the beautiful question. See the question once again, Nana. So limestone heated to temperature of 1024 degrees gives rise to what? CaO solid plus CO2 gas. The hybridization of the carbon change from dash to dash. Tell me your answers. I will give the options there. So I will give the options there. Tell me your answer. Sp3 to Sp, Sp3 to Sp2, 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 Sp3 to Sp. Now tell me, please tell me your answers regarding the options, Nana. Simple logic is there. First you think about, so what is the answer, Nana? The answer is Lakshmi said Sp2 to no. The answer is what? The answer is Sp2 changes to Sp. One of the beautiful bit, Nana. Is given in the previous paper, mains paper. Sp2 to changes to Sp. Now I am explaining how, sir. So CaCO3, Ca plus 2, CO3 minus 2. Now in the CO3 minus 2, go for the shortcut method of the hybridization. What I am saying? In the CO3 minus 2, go for the shortcut way of the hybridization. So what is the shortcut way of hybridization? Hybridization H is equal. See, hybridization H is equal. Carbon belongs to 4th group 4. Yes or no? Very good. 4 and oxygen is taken as 3 into 0 minus 2 means what? Adding out the plus 2 by 2. 6 by 2. 6 by 2 means what? 3. 6 by 2 means 3 means what? Sp2 hybridization. Simple logic, Nana. The hybridization is Sp2. I'm explaining perfectly, Nana. So the blurring image is there. I'm explaining answer the perfect. Now see that. See, CaCO3. Ca plus 2, CO3 minus 2. For the CO3 minus 2, what I am saying, for the CO3 minus 2, hybridization H is equal. Carbon belongs to fourth group plus 3 into 0. Why you take 3 into 0? Oxygen is divalent. Minus 2 means what? Adding up the 2 by 2. That means what you write now? 6 by 2. 6 by 2 means 3. 3 means what? 3 hybrid orbitals are participated, that is sp2. That is what, Nana? sp2. Now the CO3 minus 2 changes to what? CO2 gas. In the CO2 gas, carbon is there. Center atom is carbon. Hybridization H is equal. Carbon is fourth group, na? Very good, fourth group. Plus 2 into 0. What I am saying? 2 into 0 by 2. That means 4 by 2. 4 by 2 means what? 2. The hybridization is what? 2 means the hybridization is sp. And this is what, Nana? Sp. That's why. So the limestone on strong heating, the hybridization of the carbon changing from what? What to what? Sp2 changes to Sp. What I am saying, Nana? Sp2 changes to Sp. One of the beautiful bit. So 3 years back, this question is given in the mains paper. One of the beautiful bit, Nana. And go for the next bit. And for the next bit, for example, say brother, see over the ammonia bottle. See over the ammonia bottle, a few drops of HCl glass rod, kept observed a white dense fumes. Observed a white dense fumes of ammonium chloride. The hybridization of nitrogen becomes dash to dash. This is the question. See now the question. Repeat the question once again. Over the ammonia bottle. Yes, you are very well known. Ammonia is a what? Ammonia is a base, Lewis base. Few drops of HCl glass rod is kept. Observe a white dense fumes of ammonium chloride. The hybridization of nitrogen change from dash to dash. First option, Sp3 to Sp2. First option. Second option, Sp2 to Sp3, and third option, Sp3 to Sp3, and the fourth option, Sp2 changes to Sp. So the options are given like that. Please think about the answer. Just I will give the time of the 30 seconds. Please think your answer, Nana. So over the ammonia bottle, few drops of the HCl glass rod is kept. Observe a wide dense fumes of the ammonium chloride. The hybridization of nitrogen becomes dash to dash. The hybridization of the nitrogen becomes dash to dash. Tell me your answer. Sp3 to Sp2. Next option, Sp2 to Sp3. Next option, Sp3 to Sp3. Next option, Sp3 to Sp. Tell me your answer, Nana. I will give the time of the 30 seconds. I will give the time of 30 seconds. Please tell me your answer. Nana, please tell me your answer. Anyone please give your answer? Over the ammonia bottle, few drops of the HCl glass rod is placing. White dense fumes of ammonium chloride is formed. So the hybridization of nitrogen becomes dash to dash. Sp3 becomes Sp2, Sp2 becomes Sp3, Sp3 becomes Sp3, and Sp2 becomes Sp. What is the answer, Nana? Tell me the answer. Very good. So the answer is what? Avivarsha. So your answer is correct. Very good. T section, your answer is correct. The answer is so Sp3 becomes Sp3. The hybridization does not change. Very good, Nana. Himakar, option 3 is correct. Very good, Nana. Why the hybridization does not change? Yes, I am explaining. See here. I am explaining why the hybridization does not change. Yes, I am explaining here. See, in the ammonia, go for the shortcut way of the hybridization. In the ammonia, hybridization H is equal. Group number. So hybridization H is equal group number of the central atom. See in the ammonia. See in the ammonia. So nitrogen is what? Fifth group is 5. Very good. Here how many hydrogens are there? 3 hydrogens are there. That means plus 3. 5 plus 3 by 2. That becomes what? 8 by 2. 8 by 2 means what? 4. 4 means what is the hybridization? 4 means hybridization is Sp3. 4 means what, Nana? The hybridization is Sp3. Yes or no? Yes. Very good. That's why in the ammonia hybridization is what? 4sp3. Come to the ammonium chloride formation. See, when white dense fumes of the ammonium chloride is forming, in the ammonium cation, find out hybridization. Hybridization H is equal. Nitrogen belongs to fifth group. Group number of the nitrogen is what? 5. Very good. Because nitrogen is a fifth group element. 5. Plus number of surrounding atoms. Number of surrounding atoms are what? 4. Plus is there, na? Plus means what you write? Minus 1 charge is taken by 2. That means what you write, na? 9 minus 1 by 2. 9 minus 1 by 2 means what? 8 by 2. 8 by 2 means what? 4. So therefore, the hybridization Sp3 does not change. Therefore, when white dense fumes of the ammonium chloride is forming, but the hybridization of the ammonia does not change. One of the excellent beautiful point. One of the excellent beautiful point. And in this way, some bits are given in the examination regarding the hybridization shortcut way of the formulas. Regarding what, Nana? Shortcut way of the formulas. And go for the next example. And in the next example, tell me, so this question is given already in the previous mains paper. In Ethane, what I am saying, Nana? In Ethane, what is Ethane? A-L-L-E-N-E. In Ethane's, dash is the hybridization of the carbon. In Ethane's, dash is the hybridizations of the carbon observed. In Ethane's, what is the hybridization of the carbon observed? So the options are given. The first option is sp2 and sp. The second option given as sp2 and sp2. And the third option is given as sp3 and sp2. And the fourth option is given as sp and sp. Please think about your answer I have explained. Just to think. In Ethane's, what is Ethane? A-L-L-E-N-E-S. In Ethane's, the hybridizations of the carbon observed is what? Please think about answer, Nana. Please think about answer. So, in Ethane's, dash is the hybridizations of the carbons are observed. sp2 and sp, sp2 and sp2, and sp2, sp3 and sp2, sp and sp. Please think about the answer, brothers. In Ethane's, very good. Most of the members said that the answer is 2. Very good. So, but the answer is 1. Himakat, see, that is correct answer, Nana. The answer is 1. In Ethane's, the answer is sp2 and sp. So, first of all, what is Ethane? Ethane is nothing but adjacent double bond system. Tell me, what is Ethane? Adjacent double bond system. Take the best example of C3H4. C3H4 is the simple Ethane. So what is the structure of this C3H4? So this is the structure of the Ethane C3H4. It's given in the previous mains paper. So the structure of the C3H4, Ethane. Okay. Now in the structure of this C3H4, now see. So the central carbon. First of all, double bond means what? Sigma bond is a pi bond. Double bond means what? Sigma bond and pi bond. Yes. Single bond is always sigma bond. 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 Yes or no? Yes. Therefore, this carbon has how many sigma bonds? 3 sigma bonds. That's why the hybridization is sp2. Because of the carbon have 3 sigma bonds. This carbon has what? This carbon have 3 sigma bonds. Because this carbon has 3 sigma bonds, the hybridization is what? sp2. The hybridization is what, Nana? sp2. Yes or no? Where this carbon have 3 sigma bonds. And see the middle carbon. The middle carbon has only 2 sigma bonds. 2 sigma bonds means what? The hybridization is Sp. The hybridization is what, Nana? Sp. Yes or no? That's why in the rings, what is the hybridization? Sp2 and Sp hybridization is available. Simple logic, no confusion. Because of 3 sigma bonds, Sp2. Because of 3 sigma bonds, Sp2. The middle carbon is a 2 sigma bond. Middle carbon is a what? 2 sigma bonds. Because of 2 sigma bonds, the answer is what? Sp. Simple explanation, no confusion about the explanation is given in the previous papers. And go for the next example. The next example is very, very important. Is given in the previous examination paper. Now see the next example. What I am saying now, see the next example. So regarding the next example, in urea molecule, what I am saying, in urea molecule, dash is the hybridization. Is given the examination of the APMT. In urea molecule, dash is hybridization of the carbon and nitrogen atoms observed. Carbon and nitrogen atoms are observed in the urea molecule, I am asking. In the urea molecule, dash is the hybridization of the carbon and nitrogen atoms are observed. One of the beautiful bit, Nana. Now see, the options are given like this. The first option, Sp2 and Sp2. And the second option is Sp2 and Sp3. And the third option is Sp2 and Sp. And the fourth option is Sp3 and Sp3. Please think about answer. I will tell the reason. See, what is structure of urea? So this is structure of urea molecule. NH2 having lone pair because the nitrogen is a simple element. Oxygen have the 2 lone pairs, and this is what NH2. This is a urea molecule. What molecule? Urea molecule. Yes or no? Now, what is the asking question? In urea molecule, dash is the hybridization of the carbon and nitrogen atoms are observed. Now the options are given. See the options? So this is the structure of the urea molecule. Just I give the time of the 13 seconds, Nana. I give the time of 30 seconds. Please tell me your answer. In urea molecule, dash is the hybridization of the carbon and nitrogen atoms are observed. Please think about the answer. Already I give the structure of the urea also. NH2, C double bond O, NH2. What is the answer? First option is Sp2 and Sp2. Second option is Sp2 and Sp3. Third option is Sp2 and Sp. And fourth option is Sp3 and Sp3. Now tell me your answer. Nana, tell me your answer. Please think about the answer. Just I give the 13 seconds time. 30 seconds time I give and tell me your answer, Nana. So what is the answer? So Abhivarsha, your answer is 1. So Sai, your answer also is 1. Very good. Now the answer is correct. Exactly the answer is 1 is correct. Sp2 and Sp3. But most of the students keep the answer Sp2 and Sp3 keeping the answer. Most of the students think that the answer is Sp2 and Sp3. But answer is Sp2 and Sp2. I will give the reason why the answer is Sp2 and Sp3. Yes, that's correct. So most of the students give the answer correct. Very good. You follow me. Definitely you follow me. Thank you very much. The answer is Sp2 and Sp2. Very good. Now I will give the explanation why the answer is Sp2 and Sp2. Now see that why the answer is Sp2 and Sp2 I am explained. Now see that NH2. So this is what? NH2. This is have a lone pair. So this is what? C double bond O. This oxygen has what? 2 lone pairs. Nitrogen has a lone pair. Okay, NH2. Very good. This is the structure of the urea. Now see. So sigma bond taken as counting. Sigma bond is counting. Sigma bond is counting. Lone pair is counting. Yes or no? So in hybridization, sigma bond is counting. What I am saying? In hybridization, sigma bond is counting. Lone pair also counting. The sigma bonds lone pair. 8 electrons are there. 8 electrons means you think that this is Sp3. Nitrogen is Sp3. As you said, you think in hybridization lone pair also counting, Nana. In hybridization lone pair also counting. That's why the hybridization is Sp3 for nitrogen. For this nitrogen, sigma bond, 2 electrons, sigma bond, 2 electrons, sigma bond, 2 electrons. Lone pair means what? 2 electrons. That means what? 8 electrons. The hybridization is what? The hybridization is Sp3. Very good. Now come to this carbon. Sigma bond, sigma bond, sigma bond. Pi bond is not counting. 3 sigma bonds. 3 sigma bonds means what? 6 electrons. 6 electrons means what? Sp2. 6 electrons means what? Sp2. That's why most of the students think that the answer is Sp2 and Sp3. But you, most members said your answer is correct. Sp2, Sp2. Why your answer is correct? Because of lone pair conjugation. See, nitrogen lone pair double bond separated by single bond is called lone pair double bond conjugation. Is a double bond na? Is a lone pair na? Separated by single bond. Lone pair double bond conjugation is there. Lone pair na? Double bond na? Lone pair double bond conjugation is there. So because of lone pair double bond conjugation here, because of lone pair double bond conjugation here, because of lone pair double bond conjugation, the hybridization is always sp2. That's why where you have a lone pair conjugation, tell me Nana, where you have a lone pair conjugation, there the hybridization is always sp2. What I am saying? Where you have lone pair double bond conjugation. What I am saying? Where you have lone pair double bond conjugation, always the hybridization is sp2. No doubt about it. That's why you are saying answer is perfectly correct. You are saying answer is sp2 and sp2 is correct. But most of the students who said that the answer is sp2 and sp2. You follow my class very good, Nana. And go to the next example. Now regarding the next example, see this is also very important between the organic molecules. Now see this example. So what is this? So this is called cyclopentadienyl carbanion. What I am saying? Cyclopentadienyl carbanion. I am writing the name of this cyclopentadienyl carbanion. Cyclopentadienyl. What is the formula? C5H5 negative charge. This is the formula of cyclopentadienyl carbanion. Now what is the asking question? Dash is the hybridization of each carbon atom. Each carbon atom. See the option. Sp2 and Sp3 each carbon atom. And second option Sp2 and Sp2. Third option Sp3 and Sp. Fourth option Sp and Sp. These are the options. See the question once again. Cyclopentadienyl carbanion. What is that? C5H5 negative charge. Dash is the hybridization of the each carbon atom. That is the question. Please think about the question. Please think. I will give the time of the 30 seconds. In cyclopentadienyl carbanion, C5H5 minus ion. The hybridization of each carbon atom is how much? Sp2, Sp3. Next option is what? Sp2, Sp2. Next option is what? Sp3 and Sp. Next option is what? Sp and Sp. Please think about the answer, Nana. Please think about the answer. What is your answer? Most Abhiram said, Abhivarsha said the answer is 2. But Himakar said the answer is 2. Very good. The answer is 2 correct. Nice. The answer 2 correct. Again the same explanation. Why the answer 2 is correct, Nana? Simple logic is there. So what is the simple logic? So this is a CH carbon. Here CH is there. Here CH is there. Okay. Here CH is there. Here CH is there. The carbon have 3 sigma bonds. That is a sp2 carbon. Sigma bond, sigma bond, sigma bond. 3 sigma bonds are there. sp2 carbon. 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 Very good. Now see here. Here actually is a sigma bond. Is a sigma bond. Sigma bond. Negative charge means 2 electrons. 8 electrons are there. Electrons are 8. The hybridization is sp2. But because of conjugation, Because of what, Nana? Conjugation. The hybridization is what? Again, sp2. Where you have a conjugation property, what I am saying, where you have a conjugation property, the hybridization is always sp3. Simple explanation, Anna. See, I am explaining once again. So all carbons are sp2 here. Why the all carbons are sp2 here? I will give a simple explanation. No confusion at all. Go to the simple explanation, Anna. See, this is the cyclopentadienyl carbanion. You write like this. See, this is a negative charge. Is a sigma bond? Na? Yes. Is a sigma bond? Na? Yes. Okay. Is a sigma bond? Na? Yes. Go to the example. So write that example. See, I am writing perfectly here. Perfectly here. See, I got the structure. Just wait for a minute. See the structure. So I am writing the structure cyclopentadienyl like that. It is called cyclopentadienyl carbanion. See that. That is a cyclopentadienyl carbanion. That is sigma bond. Is a sigma bond. Is a sigma bond. Is a sigma bond. That is a negative charge. Again there what? Again there is a pi bond is there. See the pi bond is there. Pi bond is there. Now here CH is there. Here CH is there. Here CH is there. Here CH is there. Now check out the example. Now check out the example. See this carbon now. CH, CH, CH is there. Sigma bond, S, sigma bond, S, sigma bond. Three sigma bonds are there. sp2 carbon. Three sigma bonds are sigma, sigma, sigma. Three sigma bonds are there. sp2 carbon. Very good. Yes, CH is there. Yes, CH is there. Very good. Now see, three sigma bonds are there. sp2 carbon. Three sigma bonds are there. sp2 carbon. Yes, three sigma bonds are there. This is a sp2 carbon. Three sigma bonds are there. Is sp2 carbon. Now see, is a sigma bond. Is a sigma bond. Sigma bond. Sigma. Negative charge means what? 2 electrons. Totally how many electrons are there? 8 electrons are there. Even though 8 electrons are there, because negative charge double bond separated by a single bond. Negative charge conjugation is there. What is there? Negative charge conjugation is there. Because of this negative charge conjugation, sp2 hybridization is available. Negative charge is in conjugation with double bond. Negative charge is in conjugation with double bond. What I am saying? Negative charge is in conjugation with double bond. Negative charge is in conjugation with the double bond. Yes or no? Yes. That's why the hybridization of the cyclopentadienyl anion is what? All carbons are sp2. What I am saying? All carbons are what? All carbons are sp2 hybridized. Yes or no? One of the beautiful nice point. That's why where you have a conjugation property. What I am saying? Where you have a conjugation property, all carbons are what? All carbons are sp2 hybridized. One of the excellent nice point. Now, one more important point. Where you have a conjugation property, the bond lengths are also equal. Where you have a conjugation property, the bond lengths are what? The bond lengths are equalized. One of the beautiful, nice point. Now go to this example, Nana. Now this example. Take the example of the pyrrole molecule. Tell me what molecule? Pyrrole is a 5-membered molecule. Is a pyrrole. Now this is CH is there. Here CH is there. Here CH is there. Here CH is there. What is the formula? C4H5N. This is the molecular formula of the pyrrole. What is the molecular formula of pyrrole, Nana? C4H5N is the molecular formula of the pyrrole. Now, in this molecular formula of the pyrrole, what I am saying? In this molecular formula of the pyrrole, see C4H5N. What I am saying? C4H5N. So that is the molecular formula of the pyrrole. See, dash is the hybridization of carbon and nitrogen atoms. One of the beautiful bit, Nana. The first option is sp2. Okay, what is the first option? sp2 and sp3. And the second option is what? Second option is sp2 and sp2. And the third option is what? Sp3 and Sp3, and fourth option is what? Sp and Sp. Tell me your answer. Now the answer. Please tell me your answer. I will give the time of the. So pyrrole. The formula is pyrrole, not pyrrole. Pyrrole. Okay. C4H5N, Nana. Tell me your answer. What is the answer? Sp2, Sp3, Sp2, Sp2, Sp3, Sp3, Sp, Sp. But tell me your answer. The answer is what, brother? Second answer. Very good. So most of the students keep the answer second. The second is correct. Again the same reason, because of the conjugation property. See how the conjugation property is present. Second answer is correct, Nana. Conjugation property. How you know the conjugation property? See, lone pair double bond separate by single bond. See, double bond separate by single bond. Double bond and lone pair separate by single bond. Lone pair conjugation is there. Because of this lone pair conjugation, what I am saying? Because of what? This lone pair conjugation. So all atoms are sp2 hybridized. That's why this carbon is sp2. This carbon is sp2. This carbon is sp2. This carbon is sp2. Because of lone pair conjugation, this nitrogen also sp2. Because of what? This lone pair conjugation. Actually, you think that nitrogen is sp3. Actually, think that nitrogen is what? Sp3. But here nitrogen is sp2 because of lone pair conjugation. Because of what, Nana? Lone pair conjugation. Yes, most of the students keep the answer 2. Very good. You are saying correct, Nana. Everything you are saying correct. That's why you follow the class perfectly, Nana. Very good, Nana. And go for the next example. Take the example of the thiophene. Take the example of what, Nana? Thiophene. In the example of the thiophene, see what is thiophene. So this is a 5-membered ring system. Is a thiophene. Yes, very well known. Here what is there? CH is there. Here what is there? CH is there. Here what is there? CH is there. CH is there. So sulfur belongs to which group? Sulfur belongs to cis group of the element. In a thiophene, the sulfur belongs to which group? The sulfur belongs to the cis group of the element. Yes or no? That's why the sulfur has two lone pairs. One lone pair keep here, one lone pair is keep here. Now see here. Now, tell me, Nana. Here, one of the lone pair is in conjugation. Yes or no? See, this is what is the hybridization? See, the hybridization of, I am writing here, the hybridization of the carbon and sulfur atoms. Tell me what I am writing. The hybridization of the carbon and sulfur atoms in the thiophene. I am asked the answer. Tell me your answer, Nana. Again, the answer is what? The first option, Sp3, Sp3. So, hybridization of carbon and sulfur atom. Second option, Sp3, Sp2. And the third option, Sp2, Sp2. And fourth option, Sp, Sp. Tell me your answer, Nana. The hybridization of the carbon and sulfur atoms. Tell me your answer. What is the molecular formula of this thiophene? C4H4. Yes, this is the molecular formula of the thiophene. This is the molecular formula of thiophene. Tell me your answer. So what is the answer, Nana? First option Sp3, Sp3. Second option Sp3, Sp2. Third option Sp2, Sp2. Fourth option Sp and Sp. Tell me your answer for thiophene. What is the answer? Very good. So the answer is third option, Nana. Very good. The answer is third option. What is the reason? Again the same reason. What is the same reason? Because of lone pair double bond conjugation. Because of what? Lone pair. See, Nana, double bond separated by single bond. Double bond conjugation. Lone pair double bond separated by single bond. Lone pair conjugation. Because of this lone pair conjugation, the hybridization of the carbon and sulfur is what? Sp2 and Sp2. In this way, you have to find out hybridization in all the molecules. What I am saying, Nana? In this way, we have to find out the hybridization in all the molecules like this. This class is very nice. So the class is over. Tell me, Nana, regarding class, you have any doubts regarding the class? So in today's class, what we discuss? We discuss about shortcut way of the hybridization. Very good, Nana. The answer is third option. Very good, Sp2, Sp2 because of conjugation property. Now regarding the today class, you have any doubts, Nana? See, in the today class, what we discuss? We discuss about hybridization shortcut formula. What is the shortcut formula of hybridization? So, hybridization H is equal group number of the central atom. Tell me, group number of the central atom plus number of surrounding monovalent. What is monovalent? Single bond formation atoms plus or minus charge by 2. That is the shortcut formula. Yes or no? Yes. And in case of oxygen as divalent, in case of what? Oxygen as the divalent species, that is taken as the zero value. In case of the organic molecules, the carbon have 4 sigma bonds. Carbon have 4 sigma bonds. So sp3 carbon. Carbon have 3 sigma bonds. sp2 carbon. Carbon have 2 sigma bonds. sp carbon. That's why in the organic molecules sp3, sp2, sp hybridations are possible. But I am saying in the organic molecules sp3, sp2, sp hybridations are possible. But in the organic molecules where you have the hybridization, in the organic molecules where you have the hybridization, so the always where you have the conjugation, where you have what, Nana? Conjugation property, there the hybridization is always sp. In the organic molecules the hybridization is always sp2 because of the conjugation property. Because of what property? Conjugation property. Yes or no? So this is your today's class, Nana. Regarding the today class, you have any doubts? Abhiram, Lakshmi, and Anand Reddy. Tell me, Nana, any doubts regarding today class? Simakar, everything is clear? Yeah. So thank you very much. So this is the one of the shortcut ways. By this way, we have to find out any way of the hybridization methods. Thank you, Nana, very much.